So welcome to this video on the 2014 Section B Qb4 Hl level. So we have the three solids in contact. We have to draw the given elevation and plan showing all construction. So I'll start by drawing the plan and elevation of solids A and B. Okay, so the conical portion and the cut sphere. Now, the radius of the sphere is 32, so I'm going to show you these models in 3D. So here's the solids. Right, now note that in elevation, okay, the distance from the XY line up to the center point of the sphere is 30, and the distance from the center point to the extreme generator of the cone, so this distance here is 32, the radius of the sphere. So you do not bisect the angle between this line and this line here, the XY line. You do not bisect it to find the center. Right, I'll get started. Diameter of the cone is 78 in plan, height is 60 here, this is 22 here, so that small circle is diameter 22 in plan. So 78 from there to there. Radius will be 39. Right, as I said before, to draw in what you call it the sphere, the center point is 32 from the extreme generator and it's up 30 from the XY line. So we'll do that now. So we're going to have to go up 30 from the XY line across. Now to draw in, find the center, we're going to have to line our set square up with the extreme generator of the cone. We're going to have to draw in a line, okay, perpendicular to the extreme generator, and we're going to have to mark 32 millimeters out from the extreme generator, and we're going to have to draw a line parallel to the extreme generator through that point. So there's the center point there, and then to find the point of contact, we draw a line at 90 degrees from the center there to the point of contact. So that's the point of contact. Look, it lies in a line that makes a 90-degree angle with the extreme generator of the cone. So a 90-degree angle with the extreme generator of the cone. So we have that now. We can draw in the sphere in elevation. It appears as the XY line. And then in plan, right, the point of contact between a cone and a sphere when both solids appear a circle lies in a line joining their centers. So if you watch this now here, that's the point of contact there at this point here. Now watch this now, just in plan view, they all lie along the center. So we'll do that. So I'm just going to extend out this line. I'm going to drop down the center. I'm going to drop down the point of contact. So there's the point of contact. There's the center point. The radius remains the same. So I can draw that in, and then the cut circle where it's cut at the top, okay, is simply brought down there. So I'll let you see that here. There you can see it, and there's a cylinder on it. And then it's the height 15. Right, so that's them done. Now the next one is to draw the elevation of the hemisphere. Now two circles, or a circle and a semicircle, the distance between their centres is equal to the sum of their radii. So the radius this here is radius 50, and it's a tangent to the xy line, so the centre line is up 50. So I'm going to add on 50 to my radius of my sphere, so I'm going to add on 50. So adding on 50, I'm going to bring my compass up, swing an arc, so the centre point lies somewhere along that arc. I'm going to mark up 50. So there's the centre point there. The radius remains the same. Okay, it's 50. Now, to find the centre point exactly, we're going to join the point of contact between two circles in contact lies in a line joining their centres. So I've joined their centres there. There's the point of contact. Now, to find it in plan, I'm going to drop it right down. So there's the point of contact in plan. Here's the centre point here. Radius remains the same. So I'm going to take my compass and draw in the radius here. So that's the radius of it there, and that is part A and part A done. Okay, and essentially part C, we've all the points of contact found in both views. So part B I'll just do in a moment, we'll have to draw the development. So how I'm going to do the development is I'm going to divide this into 60/30. I'm going to extend the edge of the cone up there onto the centre line or the extreme generators. I'm going to take the true length and swing it over here and step the distances between the divisions, okay, along the arc. So I'll get started on that. So this line here, 0 to apex, is a true length because it's parallel to the xy line in plan. Okay, so I'm going to take this distance here, and I can step it wherever I want here out in the space. Okay, now I'm going to take this distance here, just where the cone is cut, to the apex. I'm going to put my compass back onto the centre point I'm just after swinging from. Okay, now I'm going to start wherever I want. I'll just readjust the focus here now. Now, I'll start at point 0, wherever I want. I'm going to take my compass and set it to the distance between 0 and 1. I'm going to keep stepping along this arc until I get back to 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 0. Until I get back to 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So label them. Now, I'm going to join apex back to 0 here. Okay, so it goes lightly from here and heavy there, because that's where it's cut. Same here. And these are all light. So join all the numbers back to 0, or to the apex. So that's then marked out. Now there's more to do. Okay, so that development I had showed you was for this surface here. Okay, we have to develop the base of it underneath. So the base is essentially the circle, and we're going to knock it along the centre line 6. So I'm just going to take my set square here, extend this line out, take my compass, set it to this radius here. So step the distance out there, and then we can draw in the base of the cone. So just to have a quick look at what's heavy and hidden detail. Alright, so there we see them in elevation. We'll turn on the heavy and hidden detail. And then in plan, you can see that's the cone there. A portion of the cone is hidden detail in plan, and a portion of the truncated sphere, okay, just in there is hidden detail in plan.